to teach you angles in the Cartesian plane. Very much important that you take note of the word Cartesian plane. Maybe let me explain what that is. A Cartesian plane is just a vertical line and a horizontal line which are named the horizontal line x-axis, and then the vertical line is being called the y-axis. Most importantly, at the point of intersection of those two lines, we have that O being the origin. So that is the point of intersection of the x-axis and the y-axis. So this is what we call a Cartesian plane. Most importantly, we know that from the origin towards the right hand side we have positive x values, and then from that same origin upward we have positive y values, which would mean this side it is the negative x values, then here we have the negative y values. Very much important for you to be aware of that. So since we are under this topic of trigonometry, so that means we will still need to involve the SOHCAHTOO. Let me just write down there and say SOHCAHTOO, just so that we can be able to see those angles in this Cartesian plane. It's definitely a tricky topic to teach. I'm just hoping that you will be able to understand as I continue. I'll try not to give too much of unnecessary information or too much of confusing information, and just stick to the basics, so that as we continue, at least you will have an idea of where we are coming from and make use of that information. So now, most importantly, you do remember very well that the ratio for sine, it is opposite over that, for cos adjacent over that, then for tan it is opposite over adjacent. So let's try and draw a right angled triangle in this Cartesian plane. The radius will always start from the origin, and it can be in that direction or any direction. Then you end up having that vertical line. Maybe let me draw it nicely there. Definitely your right angled triangle will be formed there. So whether it is there in this quadrant that we call the first quadrant, or it could be in that quadrant which we call the second quadrant, or it can still be in the fourth quadrant. This is how it will look like. And then lastly, it could be in the fourth quadrant. It will look like that. So can you see, we end up having something like a butterfly. So just be aware that it's very much easier to deal with a right angled triangle when it is in the Cartesian plane, because it will always look like this, be in the first, second, third or fourth quadrant, where the angle will be there, and then there, or otherwise there. So the nice thing about this, it's because it becomes easier to know which side is opposite, which side is hypotenuse, which side is adjacent. Something very much important that I need to mention is that this, it is our radius, which is always positive. That is the terminal arm. It is always positive. It doesn't matter whether it is in the first, second, third or fourth quadrant. It is always positive. So it is the x and y which may be positive or negative. Remember, the reason why we say it is our radius is because if we had to draw a circle, even though it's not necessarily a perfect circle, you will realize that from the center to the circumference, that is the radius. From the center to the circumference, it is that radius, it is that radius, it is that radius. I just did not draw my circle nicely there, but I'm hoping that you've got an idea of what I'm talking about. So for now, if it's your first time seeing this, do not worry that much about all these details that I'm explaining. I'm just making you aware. I'm still going to break it down as we continue, but for now, just be aware that we've got what we call the radius, which is always positive, and then we also have the quadrants, being the first quarter, second quarter, third quarter, and fourth quarter. It's like we had a circle that we now cut into 4 equal parts, where this is the first quarter, second quarter, third quarter, fourth quarter, and we refer to those as the quadrants. Maybe something very much important, let's just try to figure out which side is our opposite and which side is our adjacent, because already we have noticed that our r, it is always that radius, the hypotenuse. So definitely you will realize that this being the vertical side, it is parallel to that y-axis. Therefore, for that reason, this vertical side will always be our y, and then the horizontal side will always be our x. So already it means our y, it is the opposite. Our x, it is the adjacent. Still that same principle, if you would like, where you have this, you will always know that this side is the r side, the hypotenuse, and then if the angle is there, then this is the adjacent, and then this is the opposite. So the nice thing about having these on a Cartesian plane, it's because always this vertical side will always be our y, being the opposite, and then that will always be our x, being the adjacent. Same here, our y is our opposite, and then our x being that, and then same here, our y will always be our opposite. So that means as we continue with this topic, just always remember that our opposite is now y, our adjacent x, and then hypotenuse r. So that means this would be our y, r, x, r, then y, x. So I will no longer refer to the opposite, hypotenuse, and adjacent, but y, x, and r. The last thing, which is very much important, it's for us to establish the signs. To say, in the first quadrant, definitely you will remember that the coordinates are in this format of x and y. So what I want us to do is to check in the first quadrant, are we having positive x values? Yes, positive x values. And then what about the y values? Also positive in the first quadrant. What about the second quadrant? The x values definitely negative. What about the y values? Positive. And then let's move on to the third quadrant. Third quadrant, here we have negative x values and negative y values. Then in the fourth quadrant, definitely we are having our positive x values and negative y values. Okay, then it's fine. What else do I need to explain? There, I think it is the angles. I think it is the angles which you already know. To say, here we start with 0 degrees, and then from 0 it will add up to, let's say this is angle 0, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 90. So that angle there, it is 90. And then remember, these are the angles that we are measuring. It could be with a protractor, it doesn't matter. So now 91, 92, 93, 94, 96, 97, then until we get to that one being 180 degrees. And then 181, 82, 270 degrees. And 360 degrees. So I'm pretty much sure that now you are aware in terms of how the angles increase from 0 and then going all the way to 360 degrees. Most importantly, what we should remember is that angles which are between 90 degrees and 0, or between 0 and 90 degrees, we call these angles acute angles. I think that is the case. Then angles between 90 and 200, 90 and 180, I think those are obtuse angles. What about between 180 and 270? Is it reflex? I think it's reflex. Then what about between 270 and 360? Is it revolution? I think so. But otherwise, it's fine. And now we have our very nice butterfly there. So maybe let's now continue with the business of the day. I would like to believe that by now you will confirm to say actually sine of an angle is the same as opposite over hypotenuse, but we no longer use those, but we just say y over r. And then when it comes to cos of an angle, it will therefore be x over r. And lastly, when it comes to tan of an angle, it will therefore be y over x. That's all that I wanted you to be aware of. So now let's get to the most important part. I'm going to try and redraw that Cartesian plane, and let's do that, and let's do that. Obviously we know that here we have the positive y values, then here we have the negative y values, here we have the positive x values, here we have the negative x values, obviously with the center being the origin, being 0 there. So let's see. I just want us to try and figure out in which quadrant are we having positive trig ratios. So this is how you figure it out. Sine of an angle, it is equals to what? It is equals to y over r. Okay, we said r is always positive. So the question is, in which quadrant are we having a positive y value? Definitely, it will be either in the first and also in the second. That's why we have a positive y value. So that means this is where we are having a positive y value, and again we also have a positive y value. So that means the ratio for sine of an angle, it is positive in the first quadrant and the second quadrant. Why am I saying this? Is because if you have, let's say, positive 4 over positive 4 or 2 or any number, the answer that you will get is going to be a positive value. So now let's check maybe for cos of an angle. When it comes to cos of an angle, it is obviously the ratio of that over that. Let's see. we are actually trying to look for where cos is positive, or the ratio for cos is positive. Which quadrant will that be? Definitely in the first quadrant, cos is positive. It can't be in the second quadrant, because in the second quadrant, this is where you are having the negative x values. And it also can't be in the fourth quadrant, third I meant to say, because in the third quadrant you still have that x is being negative. So could it be in the fourth quadrant? Yes, in the fourth quadrant, because that's where you are having positive x values. So that means this is again the second place where we are having cos being positive. Okay, so now let us jump on to tan and say in which quadrant are we having tan of an angle being positive. So tan, we know it is y over x. So that means we will be looking for where the ratio gives us a positive. So let's see. What about where y is positive? Remember, again, for us to get a positive ratio, that's if again we have negative whatever y value over negative whatever x value. Let me just give you an example there so that you understand. If we have positive 4 that we divided by positive 4 or whatever, the answer will always be positive. Again, this side, if we have negative 4 and we divide it by negative 4 or 2, it doesn't matter. The answer will always be positive. So where will that quadrant be? So definitely in the first quadrant, that's where you will take the positive y value divided by the positive x value, and that will mean in the first quadrant the ratio for tan is positive. What about in the third quadrant? Even in the third quadrant, because you have a negative y value that can be divided by a negative x value, and it will end up giving us a positive value. So that means, honorable members, or a member who is honorable, sign it is positive in the second quadrant, and then that is positive in the third quadrant, and then that is positive in the fourth quadrant, tan in the third, and then all of them are positive in the first quadrant. So that is why we can just say all of them are positive in the first quadrant. Very much important that you therefore realize that this thing, they end up calling it the cast diagram. Why the cast diagram? Is just to make it easier to remember. Cast diagram. Otherwise, your teacher may say A for all, S for singers, T for take, C for cough sweets. Meaning, all singers take cough sweets. Yeah, if you are a singer, you will relate. Sometime when you sing, you will need that special sweet, for the cough sweet, something of that nature. But for me, I'll just stick to cast diagram. It's easy to say cast diagram instead of saying about all singers taking the cough sweets and all of. Okay, so now again, do not worry that much. I'm just exposing you to a cast diagram so that in future there's going to be a day where you need to come back to this lesson and do a revision on it, because it is very rich with information and it will make it easier for you to understand where the cast diagram is coming from and all of that. And in case if you come across questions that requires the cast diagram, you know where to go. It's fine. So now there is an exercise that we are going to do together here. For this exercise, I will not necessarily want you to do it just like the other exercises. We will just do it live, because you will definitely need to master this before the next lesson. Okay, let's see. Let us say they are asking to say in which quadrant does the terminal arm of the angle lie. So it's like, if you remember, we said this being the Cartesian plane. So we are just trying to figure out if this R is going to be in the first, or if it's going to be in the second, the fourth, or the third quadrant. Yes, we're just trying to figure out in which quadrant will that terminal arm lie. So A, sine angle being greater than 0, and cos of an angle being greater than 0. So it is very much important for you to be able to interpret this thing, because it will help you to know in which quadrant your right-angled triangle fall. That's actually what we are trying to figure out indirectly here. So how are you going to do that? So just be aware that this is what is going to guide you. This. The greater than, the smaller than, sign, it is the one that is going to help you to know. So interpret it this way. When something is greater than 0, that means it is actually a positive value. When something it is less than 0, we are actually talking about something which is actually a negative. So the moment you are given sine of an angle, think of it as y over r, whereby r, I said, is always positive. So for us to have an answer which is greater than 0, that's if y it is also positive. And then let's jump on to this other one. For us to have an answer which is greater than 0, it simply means a positive answer. So that means what we know is that cos is the ratio of x over r, where r is always positive. So that means x is also forced to be a positive, so that the answer is greater than 0. So when you look at it, it's like we are just looking for a quadrant whereby we have a positive x value and a positive y value. Which quadrant is that? Definitely it should be the first quadrant. Yes, based on my interpretation, or based on what I've just explained there, it means it should be in the first quadrant. I'm not sure if it makes sense, but remember, don't just do this as I'm doing it and then it ends there. Nope. Try to redo it, and trust me when I say, if you try to redo it on your own, that's when it's going to make sense. So an answer to this question whereby they are asking in which quadrant does the r of the angle lie, if we are given sine angle greater than 0 and that greater than that, so you can just say first quadrant, or maybe you can just say quadrant number 1. There will okay, let me say there may not be a question which comes like this, but they will give you another question whereby you will need to interpret this to know in which quadrant you are going to have your right angled triangle. So it's fine. Let's jump on to another question. Let's say B. Then when it comes to B, let's say for B they are saying whereby sine of an angle is less than 0. That being less than 0, you should just interpret it as something being positive or negative. That's all that you need to interpret. Let's say this of an angle, again, let's say less than 0. So your approach should be sine of an angle, sine is y over r. R is always positive. So for you to have a value which is less than 0, it has to be negative. So that means it should be negative over a positive. It will definitely give us a negative y value. And then this one, cos, we know is the ratio of that over r. R is always positive. For you to have a value which is less than 0, that's if you say negative over positive. Doesn't matter what the number is, as long as you have that ratio, it will give you a value which is less than that. So it's like less than means negative, not just less than, but less than 0. Less than 0. And then something which is greater than 0, it means a positive value. Interpret it in that way, it's going to be easier. Then now what you do, you just take your x value being negative, and then you take your y value being negative. Then you go to your Cartesian plane to find out in which quadrant are you having x being negative and then y being negative. Definitely it should be the third quadrant. It looks like you just need to have this thing ready to say in the quadrant these are the values that we are having, and then in the second quadrant it's x which is negative, but y it is the one which is positive, and then in this quadrant it is x which is negative, and then y it is negative. It looks like that's what you need. X is definitely positive here, and then y it is the one which is negative. Can you see? So let's jump on to the next question and see what they are saying, and based on that we will choose accordingly. Question C. Now they are talking about tan of an angle being less than 0. We know what that means. And again they are saying cos of an angle being less than 0. Okay, again same approach. You need to say the ratio for this is y over x. So for us to have a negative value, that's if one of these two is negative, the other is to be positive, the other has to be negative. So since we are not sure whether it is this which is negative or this which is positive, we can just leave it for now and then try to deal with this one. To say for this one we know that it's x over r, that has to always be positive, and then for us to have a negative value, that's if x becomes negative, then it forces this x to be negative. I will tell you why. Let me draw that Cartesian plane and say when we look at this one, x is negative on this side and is positive on this side. So that means our point of focus is this side whereby x is negative. So that's how we know that this x has to be negative. It is because of that one there. So that means if this one was positive, it was going to force this one to be positive. Now for us to have a negative there, that's if this one is positive, and for that to be positive it means it is in this quadrant, and that's how we will know that actually that to be negative, and then let's see, that to be negative, yes, it will therefore be in the second quadrant. So that's how you would answer this question. So what if, one may be wondering to say, what if it was greater than? So that means if there it was greater than, it means let's see, it would therefore means we are talking about a positive x value there. So if we are talking about a positive x value there, we can't put a positive there because we said this one, it is the one that forces that x to be negative. Okay, so that means the x will remain as negative. But for us to have a positive, then it means we are forced to also have a negative y value, because negative over negative is positive. Then it means this is the quadrant in which we are going to look at and say it actually falls in the third quadrant. So I was just giving you an example to say if it was falling in this quadrant, yes, if it was falling in this quadrant, this would be the situation. If it was falling in that other quadrant, this would be the situation. Or if there it was that, yes, something of that nature. Okay, then it's fine. Let's look at another one. And what else can we talk about there? Okay, let's say maybe we have this one. So remember, some of these things you need to do them as many times as you can until they make sense. You don't just watch one lesson and then same time everything makes sense. So what I'm doing now, I'm teaching you the worst case scenario whereby they can give it to you in this way. But trust me, for me, I never had to deal with this type of things, but I'm just making you aware so that in case if you come across this, you won't just be lazy to interpret it, but you will at least try work out something. And how you start, you will always say, okay, here I'm expecting a negative ratio, and then even here I'm expecting a negative ratio. To say, okay, I forgot to use that other one in terms of the x and the y, to say in which quadrant are we having the x or y and the y, but it's fine, I'll do it here. So you just need to remember that here we have y over x. And again, you can never be sure whether the negative goes there or it goes there, and the positive goes there or it goes there. Why? Because it can go to one of those. So it looks like when it comes to tan, you will just have to take a pause and focus on the cos and the sine, because the sine is straightforward. Why am I saying it's straightforward? It's because r is always positive. So therefore, this has to be negative, because they said cos less than 0. So now that cos is negative, it forces this one to be negative. Can you see how it works? And then because that statement we are expecting a negative answer, then this one has to be positive. And you see. So it therefore means we are looking for that quadrant where we have we are having negative x value, then we are having a positive x value. That's how we will know in which quadrant it falls. Based on this is where we are having a negative x value and a positive x value. So with this one, again, you see there and there, it is a negative x value, and then having that being a negative y value. That's how we would know that it falls in the third quadrant, because in the third quadrant, that's where you have a negative x and a negative that. But if it was a positive, then you see x being negative, y being positive. That's how we knew it falls in that quadrant. Yes, I think now we are coming with it nicely, to say if you have tan and cos that you have to interpret, or tan and sine that you have to interpret, just do the ratio for tan, leave it as it is, and then focus on the cos or sine, and then allocate the signs, and then from there it forces for that other one, then you will choose the other one to be positive or negative. Maybe let's do which one? I think it's E that we have to do. So this one, it comes in a different way. They are saying sine of that, let's say less than 0 there, and maybe let's say what? Let's say, and this time around they just say that being the element of 90 degrees and 270 degrees. I don't have space there. Nope. Let me just do it nicely. I don't have space, but let me just rewrite it there and say, and angle being the element of 90 degrees and 270 degrees. Yes. Okay, so what happens here is that if you remember, we said our Cartesian plane angles start from 0 and 90, 180, 270 and 360 degrees. This one, if it's given in this format, just know it's nice. The reason why I'm saying it's nice is because they're simply saying focus on this quadrant from 0 to 270 degrees. So it's either it is in that quadrant or that quadrant. For you to know exactly in which quadrant, this will therefore confirm. So what we know is that sine, I don't even need to rewrite it, sine is the ratio of y over r, whereby r is always positive. You remember I said that. So sine being less than 0 means negative. So that means you need to have a ratio whereby here it will definitely be negative, because when you say negative number over positive number, it gives a number which is less than 0. You remember the number line we have negative maybe 3, negative 2, negative 1, and then you have 0, and then you have positive 1, 2, 3. Same principle. All the values on this side, they are less than 0. Why? Because they are negative. All the values on this side, they are greater than 0. Why? Because they are positive. So just always interpret it in that way. So okay, now we will say in which quadrant will this fall. Definitely it should be in the quadrant whereby y is negative, and for that reason it will be in this quadrant, because that's where we have negative y value. So therefore it means this one, it falls in the third quadrant. That's how you figure it out. Let's maybe do the last one, and from there we should be done. So the last one, F, let's see. I'm curious if you would like to have some questions that you can use as a practice. I think I will give you those just so that at least you can test yourself. But before you can do those, try to redo these examples that I've done and then see if they can make sense. Definitely not easy to teach this thing because it needs someone who is well experienced in mathematics. Okay, then it's fine. So now let's see. Again, this thing still nice because it is that one whereby it's more like we're saying x being the element of, now here being 0 and 180 degrees. Just interpret it that way. So what it simply means is that on that Cartesian plane, if here it's 0 degrees, 90 degrees, here 180 degrees, here 270 degrees, and then there 360 degrees. It's like they are saying between 0 and 180. So that means they are saying just focus there and there. It could be there, it could be there. You are not sure, but this statement will confirm it, where they say negative ratio. So if it's a negative ratio, I think already it's obvious, because cos is the ratio of x over r, whereby r is always negative, and for us to have a negative value as if x is negative, and negative is always on this side of the Cartesian plane, which means it falls in that quadrant. So when I say it falls in that quadrant, as we go deeper with the questions, you will find that they give you those two statements, and then from there you need to figure out in which quadrant it falls. If it falls in the first quadrant, that means your right angle triangle. You will therefore draw it in there like that. And then the questions that you'll be asked, you will just be using what you know. a theorem of Pythagoras or tan or cos or sine, where you find the other sides and then you are done. And then if you manage to find out that it falls in the third quadrant, this is where you will draw it, and then there you are, and then you are having your y and then your x. You just use theorem of Pythagoras or whatever. If you figure out that it falls in that quadrant, then easily you can draw a right angle triangle easily and you work it out. Or if you manage to find out that it falls in this quadrant, then you will draw it like that, knowing that it falls in that, then you will easily do the necessary calculation. So if you don't know in which quadrant it falls, then it means you won't be able to solve the questions, because the questions that will come will be based on you knowing in which quadrant your right angled triangle falls. If you do not know, then you are definitely going to be in a big trouble. So yes, maybe let me make you aware to say in most cases you will be given something of that nature which you will use in order to know in which quadrant your thing falls. Because maybe let me not say much and just wait for the next lesson, where I will teach you in terms of how it may come in real exam type of examples. Yes, maybe for now let me leave it here, and I think I will definitely give you a very quick exercise to do, just so that you can test yourself if you can figure it out correctly in terms of in which quadrant whatever falls. So I'm thinking that let me leave it here and say until we meet again. But also, please be aware that it's not an easy thing to teach, not an easy thing to understand. So you might need to repeat this lesson over and over and over again, especially if you did not fully understand, or when you attempt these things on your own, you just did not understand. Because I'm pretty much sure that all that I explained, it does make sense, but you may not instantly be able to apply it. Just like you see our nice butterfly there. When someone just looks at these, they will just think, this is difficult, this is complicated, you don't know where to start. But because you started from the start, you know what color represents what and what was being explained there, and there's nothing new. Definitely, as I was continuing, some of these things may be new, but they should make sense. It looks like the most important thing to understand or know, it is the Cartesian plane. Once you fully understand the structure of a Cartesian plane, knowing that it has 4 quarters, in those quarters you have the x being positive, y being negative, or vice versa, whatever the case may be, and how those can be interpreted in terms of the cos, the tan, and the sine. It's just 3 things that you are comparing, honorable member. So I think, yes, let me leave it here and run away and say until we meet again.